Hi, in this video I'm going to talk to you about factoring binomials. So that prefix bi stands for 2, and so this method specifically works with when you have 2 terms in the expression. Now, all of the examples that I'm going to show you on this video are what is called difference of squares. Difference of squares, okay? So let me just break that down for you. The word difference means subtraction. So the only problems that I'm going to show you on this video are subtraction problems. And difference of squares means that both numbers or both terms in each of these problems will be a perfect square number, okay? So just real quick, a perfect square number means that you can take the square root of these numbers and get a whole number as the result. So 36 is a perfect square number. K squared is also a perfect square number because k times k. And then 4 is also a perfect square number. And so that's how the name of this method is called difference of squares, okay? And actually, once you identify that you're working with a difference of square, it's pretty easy to come up with the answer. So let me show you how with this first example. Okay, before we get started on this one, I want you to first look for a common term, okay? 36 and 4 both have the factor 4 in common. I want you to pull this out. That leaves us with 9k squared minus 1. Those two terms inside the parenthesis are still perfect squares, and it's still a subtraction problem, so we still have a difference of square. 4 is going to stay in our answer. And our answer, I want you to go ahead and draw two parentheses out. And we're going to unfoil this in a way, but there's actually a shortcut, once you figure out this is a difference of squares. These are both going to be binomials, so there's going to be 2 terms in this parenthesis and 2 terms here. And the first spot of each parenthesis will be the square root of the first term in the problem. And so if you take the square root of 9k squared, you get 3k, and I'd like for you to write that as the first term in the parentheses. Next, if you take the square root, now I want you to ignore that -1, or the negative sign right now. If you take the square root of 1, it's 1 and 1. So we're going to put a 1 here and a 1 here. Now, the operations we're going to put 1 plus sign and 1 negative sign. Now the reason we have to put 1 plus sign and 1 minus sign is because if you notice the difference of square, there's only 2 terms where usually if it's a term that's been squared, like a variable squared, it's usually a trinomial. But because we have these different signs right here, when you go to refoil this back out, and I'll just show you this really quickly as an example. If you do the first term, there's your 9k squared. And then if you do the outside, this is negative 3k. The inside is positive 3k. And then the last, I don't have room to draw it. There we go. The last is your negative 1. Look what happens right here. That negative 3 and positive 3 cancel. And so that is how it became a binomial instead of a trinomial. So it's super important for your answer to one of the terms to be plus and one of them to be minus. So if I go back and erase these little lines, okay, your answer for this problem is 4 times the quantity 3k plus 1 times 3k minus 1. Okay, take a look at this next one. This is another binomial, and so there's really just 2 choices when you're factoring a binomial. The first one is to look for a common factor, and then we can check and see if it's a difference of squares. So if we look at our two terms, notice they're both even, so we can pull out a 2. Okay, and that leaves us with x squared minus 9. The x squared and the 9 are perfect squares, and it's still a subtraction problem. 2 is going to remain in our answer. Then I want you to draw 2 parentheses. The first spot of each of these parentheses will be the square root of the first term. So the square root of x squared is x times x. These last terms will be the square root of the last term up here, which is the square root of 9 is 3 and 3. And then it doesn't really matter. One of them just needs to be positive and one needs to be negative so that that middle term cancels out. So we'll make that negative and this one positive, and there you go. That's the answer to this problem. Okay, you have one more problem that I want to work with you. Take a look at this one. This one appears to look harder because it has 2 variables instead of 1, and so it just makes it look complicated, but it's really not so bad. The first thing I want you to notice is that there is not a common factor. And so we are just going to start with this, but even though this x squared, y squared may look a little different, a little harder, it really is a perfect square number. It's xy times xy. And then of course 81 is a perfect square number. So you can go ahead and just draw those 2 parentheses. Take the square root of the first term and write that in each of the first spots. And then take the square root of the second term and write that down. And then here it doesn't matter. One just needs to be a plus sign and one needs to be a minus sign. And there you go. There's your final answer. Okay, now I want you to try some of these. Pause the video. There's going to be some problems that I want you to solve, and then you'll see the answers pop up on your screen too.